Here's an airplane example. An airplane is heading north at an airspeed of 650 kilometers per hour, but there is a wind blowing from the southeast at 60 kilometers per hour. The plane will end up flying how many degrees off course? The plane's speed relative to the ground will be blank. Okay, so it's a vector problem. So let's draw a vector coordinate system down here. Okay, remember our directions. This is north, south, east, and west. Okay, the airplane is heading north at an airspeed of 650 kilometers per hour. So here's the plane. It's heading north, 650 kilometers per hour. That's his vector. That's the plane's vector. Okay, but there's a wind blowing from, notice what it says there, from the southeast. So where's the southeast? This is southeast right here. The wind is from the southeast, which means the wind is actually blowing. If it's going from the southeast, that means it's blowing northwest. Right? If it's from the southeast, then it goes from the southeast, and blows up to the left, doesn't it? So you don't really need, let me get rid of this little part here. All right. Okay. So to make that vector easier, so there's the wind vector. And what is it? 60 kilometers per hour. So that's the wind vector. Okay, so what's the deal? Well, these two vectors added up are going to form the resultant vector. That's the game plan. So step number one, write the vectors, well, I should say, find angles from 0 degrees counterclockwise, because that's how we measure angles, right? They could have made 0 straight up. They didn't. They made 0 right over here, so we got to do all our angles. So for the plane is at an angle of 90 degrees. And the wind vector, what's the wind vector all the way to there? That must be 90 plus 45, because it's right on the diagonal. So that's 135 degrees to the wind vector. So the wind vector is at 135 from 0. The plane's at 90. And so step 2, change vectors to x, y, where x is m cos theta, y equals m sine theta, as long as the thetas are these kind of angles, right? From 0 degrees counterclockwise. Okay. Step 3. So let's do that. So we've got the plane vector. First off, that's going to be x is going to be 650 cosine 90, and y is going to be 650 sine 90. If you do this on your calculator, this one's 0, and this one just comes out 650. That makes sense, doesn't it? The plane vector is just straight up. So it's all y. There's no x to it, of course. It's straight up 650. Let's do the wind vector now. So the x again, wind amount is 60. 60 cosine of the angle. What's the angle? 135 for the wind, right? And the y is 60 sine of 135. So using my calculator, I'm getting minus 42.4264, and the other one is the same thing but positive, 42.4264. And that makes sense, doesn't it? That the wind is back and up. So it's negative on the x, positive on the y. That makes sense. Okay, so now step number 4. Add the two vectors to find what's called the resultant vector. You take engineering, physics, they'll talk to you about finding the resultant vector, the result of the wind and the plane. The plane's engines are trying to push the plane straight north, but the wind is trying to push the plane up left. The net result is going to be some kind of vector that's in between the two of them. That's going to be the resultant vector, we call it in engineering and physics. So let's do it. How do we find that resultant vector? So we add the x with the x, so the resultant vector, the result of the wind and the plane together is going to be the x plus the x. So it's x from the plane plus x from the wind, which is 0 from the plane, plus negative 42.4264. So that's just negative 42.4264 because the wind's the only sideways vector, and then the y from the plane plus the y from the wind. And what's that going to be? The y from the plane is 650 plus the y from the vector is 42.4264. So you add those together, we get 692.4264. All right, so we've got the resultant vector, the x and the y of the resultant vector. What do they want from me on this problem? They first off are asking me how many degrees off course and then the speed. So this resultant vector is back and up. So you could put it right here. It's going to kind of make this diagram a little messy, I'm afraid. Guess I could do it. Try that again. It's going to go like this. Something like that. That's going to be the resultant vector. It's going to go left and up, you see. Left and up. The resultant vector is left and up. How far left is it? Well, it says left 42.4264. 42.4264. And then up, what was the up? 692.4264. 692. Up. So it's left and up is the result of the plane and the wind. The plane's engines and the wind blowing has the result that the thing actually moves. The result of those two is it actually moves up to the left like that. Right? No big surprise. Okay, so they're asking us exactly how many degrees off course. So what's that going to be? How do we find that angle there exactly? How are we gonna do that? Well, let me suggest that probably the easiest thing to do on this problem is we're basically trying to find the vector angle, right? The angle from here, theta, and then we can just subtract 90 to find how many degrees off course it is. So the vector angle, remember how to find a vector angle. So this is a long problem. Step 5. To find a vector angle, so this is an important process. Vector angle, step A, take tangent inverse of absolute value of y over absolute value of x. You got to make those positive. So tangent inverse, the y is 692.4264. The x, you're going to make it positive 42.4264. Well, I hope that makes sense because it's the absolute value of the negative, and this is the absolute value of the regular. So that makes it positive, doesn't it? So why are we doing the absolute value? absolute value makes it positive, so it's a first quadrant angle. Remember, all the trig functions are positive in the first quadrant. The all students take calculus, they're all positive in the first quadrant. So by making it positive, all the y and the x positive, and doing the tangent inverse, you're finding the angle in the first quadrant, but it's not in the first quadrant, right? But then we'll change it. This is the best way. This is the easiest way. So let's do that. So this is tangent inverse. Oh, I already wrote it there, didn't I? So let's just get the answer there. So that's your angle. That's your angle. So theta, that's your angle at first. Tangent inverse there. I'm going to hit the buttons on my calculator. Tangent, make sure you're in degree mode. 692.4264 divided by the other one I'm getting 86.49375 degrees. Now that's, again, first quadrant. And then so you got another step here, an important step. Step B, change to the correct quadrant. Change to the correct quadrant. So we get tangent inverse of y over x. And so now we've got to change this to the correct quadrant. So what does that mean? Change to the correct quadrant. Well, this is first quadrant, meaning from the x-axis. So that's the angle from the x-axis. So if we go into the second quadrant, our angle, our vector's here. So this is the angle from the x-axis. This is 86.49 degrees from the x-axis in the second quadrant. We know it's second quadrant, right? Because in reality, the vector is back and up. It's back and up, right? It's x negative, which we changed to positive, and y up. So that gives you, and so that gives you the right quadrant. And then this 86.49 thing is from the x-axis. So from 180 degrees. So just like those formulas we had before, quadrant 2, you've got to take 180 minus the theta. So that's 180 minus the 86.49375. And I get 93.5062 degrees. That's the actual angle from 0 degrees. That'll get you the actual angle from 0 degrees. So the real angle is 90. So everybody see how we do this? You really need to know this number 5 here. Spend time watching this section over and over again until you get this down. You have to be able to find vector angles. And here's the process I'm giving you. Tangent inverse of the absolute value. Make x and y positive. That way you get a first quadrant answer. This, which means what? Which means that's how far it's from the x-axis. But then you change to the correct quadrant. You change to the right quadrant. So what is the right quadrant in this case? Quadrant 2. We already know the resultant vector is in quadrant 2. So it's 86 degrees from the x-axis in that quadrant, which means it's 180 back up the 86. 180 minus 86. Get the 93. So that's the actual angle, that means, from there is the 93.5062 degrees. That's the actual angle of the vector. So if we're going back up to here, that means from here to there is that 93.5062 degrees. So how much off course is it? It wanted to go straight up, which would be 90. So how far off course? You got to take the 93.5062 degrees and subtract 90 degrees, which leaves you with 3.5062 degrees. That's how far off course, right? Because it wanted to go straight north. It was trying to fly straight north 90 degrees. How far off of 90? It's really flying at 93 degrees, so it's off a little bit. It's off a little bit there. 3.5062 degrees. Finally, the plane's speed relative to the, what do they mean relative to the ground? Well, you take physics, you'll learn more about this. You know, we had an air speed. That means relative to the air. That means as you're moving through the air, it is moving straight north through the air at 650 miles an hour. But the trick is the air, the wind is blowing northwest. So in the end, it's moving relative to the ground, like a person on the ground, in the resultant direction that we have right here, which is a little different than the way it was aimed in the air to go straight north. And then the speed relative to the ground will be the magnitude of that resultant vector. That's the magnitude of the resultant vector. So this is a long problem. Final step, speed relative to ground is the magnitude of the resultant vector. Magnitude of the resultant vector. How do you find magnitude of a vector? Square root of x squared plus y squared. That's like the Pythagorean theorem. So square root of x, what was x? Let's go back, get the vector. The x and the y. Up here, the resultant vector. Right? Here's the x. Here's the y. 42.4264 squared plus 692.4264 squared. On that, so you put those in your, those are the numbers, right? Yep. Put those in your calculator. So that'll give you the magnitude, which is the ground speed. That's the magnitude of that vector. That's the result, speed-wise, of that vector. It's the result of the wind and the plane's engines. And I'm getting 693.7249. 693.7249. That answer goes up here. It's actually this blank. I wrote the other thing in there. 693.7249. That's the kilometer. That's what the plane will actually do. That's, in the end, that's how fast he's going to actually go relative to the ground, which is actual speed. So he's gonna do that. So in other words, the wind speeds him up a little bit, right? He was doing 650 straight north. That's what his engines were pushing through the air. But then the wind blew up to the left, so that sped him up a little bit and pushed him a little left of straight north, left by 3.5 degrees, and sped him up to 693 kilometers per hour. So that's pretty complex. It's all about taking those two vectors, writing them from 0 degrees, and then changing them with x equals m cos theta, y equals m sin theta to x and y vectors, adding them up to get the resultant vector, and then from the resultant vector, we got to find vector angle, which is always hard to do. That's tangent inverse of absolute value, and then change it to the right quadrant. That was a big pain. And then 93 is what came out, and then we had to subtract the 90 because they asked off course. And then finally, speed relative to the ground, that's the resultant vector, square root of x squared plus y squared. Tough problem. Make sure you can do it. Very important.